If you take the same material, why does it behave differently when it becomes nano-sized? Why does size changes everything? Welcome to Zidyep, and today we'll be talking about the difference between bulk materials and nanomaterials and why materials behave differently at nano-sized scale. So, the definition of bulk materials. Bulk materials are materials at the normal larger scale where their properties remain relatively constant. Nanomaterials, on the other hand, exist at nano-sized between 1 and 100 nanometers, where they begin to show unique properties. We have seen bulk materials countless times in our previous episodes, and also nanomaterials, and we have always said that it is between the range of 1 and 100 nanometers. So, but why does change happen? Why will a material at bulk size behave differently from a material in the nano size? The first reason is the surface effect. And one major reason is the increase in surface area. As materials become smaller, more atoms are exposed on the surface. But here is something interesting. If nanoparticles are smaller and contain fewer atoms, how can they have more surface atoms? This is a very important question, and let me say it again. But here is something interesting. If nanoparticles are smaller and contain fewer atoms, how can they have more surface atoms? So the answer is, it's not about the total number of atoms, it's about the percentage of atoms on the surface. In bulk materials, most atoms are inside, but in nanomaterials, a large fraction of atoms are on the surface. In bulk materials, most atoms are inside, as you said, and in nanoparticles, a large fraction of atoms are on the surface. Like, for example, I came to ask the question that why is it that bulk materials, the total amount of atoms are more than the total amount of atoms in that of nanoparticles? But how comes does the nanoparticles have more? Most times they claim that the nanoparticles have more atoms on the surface. But then we tend to understand that why nanoparticles behave the way they do. It's not because of the total number of atoms, but the percentage of atoms on the surface. The fraction of atoms on the surface is more than the fraction of atoms beneath it, inside it. But the bulk materials, the percentage of atoms inside, it's more than the percentage of atoms on the surface. So it's not about the total number, it's about the percentage of atoms. So even though nanoparticles have fewer atoms, a much larger percentage of them are exposed on the surface, which is what you just said. And secondly, the second reason is surface effect. These surface atoms are more reactive because they are not fully bonded. This leads to changes in properties like chemical reactivity and surface energy. Basically, what this is saying is that surface atoms are more reactive because they are not fully bonded. They are not fully bonded at the surface. They do not have more neighboring atoms than the one inside it. So, which leads to changes in properties like chemical reactivities and surface energy. And the third reason is the size effect, which is also called the quantum effect. At this nanoscale, materials can also change size dependent on quantum effect. This affects how materials interact with light and electricity. And let's take an example for that. Large zinc oxide particles behave differently under light, like large zinc, bulk zinc oxide. It behaves differently under light compared to nano-sized oxide, nano-sized zinc oxide. This is why nanomaterials are used in applications like sunscreens and electronics. You know, sunscreen, what they use to protect themselves from, let's say, the people without melanin, they use it to protect themselves from sunlight. So sunscreens and electronic, that's if I'm right, that's what sunscreen actually, because I'm in a bit of doubt right now. So, and electronics. So this is a real example of how a large zinc oxide, which is in bulk, and this is the same material, but they behave differently when it's in nano size and when it's in the bulk material, when it's in its full form. So the difference between bulk and nanomaterials comes down to three main factors. Number one, increased surface area, surface effect, size dependent effect. So this is why size matters in nanotechnology, because changing size changes behavior. This is why nano is this is why so basically what we have said throughout this is that materials tend to behave differently when they are in bulk materials and also when they are in the surface size. Why? Because of three reasons. Number one, the surface effect, the size effect, and also thirdly, increased surface area. Increased surface area, surface effect, and size dependent effect. So these are the three reasons why a material like zinc oxide will behave differently under light when it's in its bulk form and also when it is in its nano form. So this is basically what we're talking about today, and I hope you understand, because it's clearly the concept is clearly not too complex. So I hope you understand, and this is the outro. This is Nano with Zidyep, where I document my journey of learning nanotechnology step by step. If you're interested in nanotechnology and material science, come learn with me. Thank you for listening if you have listened to this point, and peace out. I'll see you in the next video where we talk about quantum physics, and peace out.